Hi everybody, today we are talking about comparing irrational numbers. To start off, quick reminder, you do not need to write down everything that I talk about in this video, but be sure to jot down important information and at least one example of each type of problem that we cover today. Remember that you can also use your pause button to jot down important notes before moving on, your rewind button to view information again, and the fast forward button if you think you got it and you want to move on. But be careful. Be sure that you don't fast forward too much and you miss out on something important. The only thing that we have to talk about before we go over some example problems is review how to approximate square roots. So what does that mean? Remember that when you have an imperfect square root, like the square root of 32, you're going to want to look at your perfect squares and then see which two perfect square roots it falls in between. Sometimes you're going to have to go to the nearest tenth, because today when we're comparing irrational numbers, we're going to be given a list of different irrational numbers and we have to put them in order or compare which one is greater and which one is lesser. So you might have to look at the nearest tenth, but just know that you're finding two perfect square roots that it falls in between. All right, let's take a look at some examples. Here is one question that you could be asked. It says, without using a calculator, order the following expressions from least to greatest. Go ahead and pause the video and see if you can solve it yourself. Okay, let's try this out. So we want to go from least to greatest, so the smallest is on this side. And then the greatest, the biggest value, is on the right-hand side, just like a normal number line. All right, I have one whole number here, 2. I don't need to do anything to that. And then I have two different radicals here that I'm going to need to do a little extra work to figure out what their true values are. And again, I cannot use a calculator. So let's start with square root of 3. Actually, I need to list all my perfect squares first. And I'm going to start low because those seem pretty low. So I have 1 and 2 and 3. All right. So let's see, square root of 3 is going to be somewhere over here. And then I have square root of pi. So square root of pi is actually, let's see, pi is 3.14. Goes on forever, but we'll just leave it there. So the square root of 3.14 would be somewhere right after it. Let me put pi actually, or put my 4 better. Okay, so first goes 3.00, then it goes 3.14. So then we have to figure out, so here we already know what's less and what's greater. The 3 is obviously less than 3.14. Now where is 2? 2 would be right here. So we have square root of 1 as the smallest. Then we have square root of 4, and then we have square root of 9. So 1 is equal to, square root of 1 is equal to 1, square root of 4 is equal to 2, square root of 9 is equal to 3. So it looks like, let's see, square root of 3 was right here, and then square root of 3.14 was next, then followed by 2. So we have square root of 3 first, then square root of pi, then we have 2. Okay, so we kind of put them all on a number line. They all seem to be pretty close to each other too. Okay, so putting it out here with the radicals should help you out. So that means I need to move the square root of 3 and the square root of pi to the front. So that it matches the order. Okay? Let's go on to the next question. Without using a calculator, match each expression to the correct point. Go ahead and try and figure this out on your own first. All right. So it looks like these, oops, oh, that's why I have my pen still on. These people can move. Okay. So let's see. This one right here is right on 7. M is right on 7. We need to figure out the radical for 7. 7 is the same as the square root of 49. Okay? And 8 is the square root of 64. So all I'm doing is I'm putting my perfect squares down so I can figure out what's going on. So m is definitely square root of 49. This one's good. We don't need to move it. It's already there. N looks like it's somewhere between 49 and 64, but kind of smaller. So it's probably like early 50s, I would say, right? So that's perfect. It's right here, square root of 52. So that makes sense if that one's square root of 52. And then this O point is very close to 64, but a little bit less than it. So it would be like early 60s, and they have a square root of 63. It's super close. It's like literally the number right before it. Okay, so we got it. We got m is square root of 49. That's already set. And then these two have to switch because it goes 52, then 63. So let's fix that. Okay, that's pretty much what that is. Let's try this one on your own first. Without using a calculator, order the following expressions from least to greatest. So go ahead and pause your video. All right, let's take out our pen. Least to greatest. Ooh, there's a lot going on here, and we cannot use a calculator because my first instinct is like, what's pi divided by 3, right? A lot of these are divisions, so let's see if we can figure it out a little bit more. Pi divided by 3 would be about 3.14 divided by 3, okay? So 3.14 is kind of like 3 divided by, so we're kind of estimating it to 3 divided by 3. So it's about 1. I would say it's a little bit more than 1 because it's 3 and some change divided by 3. Okay, so it's not exactly 1, it's a little bit more than 1 because of that some change. It's a little bit more than 3 divided by 3. So I would say it's about 1.1. For square root of 2, for square root of 4 divided by 2, that square root of 4 is exactly 2. 2 times 2 is equal to 4. 2 divided by 2. 2 divided by 2 is exactly 1. This one is exactly equal to 1. Notice how I use an equal sign here and a squiggle, like kind of, okay? And this one's not exactly equal to 1. We don't even know if it's 1.1. We're just kind of estimating because it's a little bit higher than 3 divided by 3. Normally, if it were 3 divided by 3 exactly, it would be exactly 1. But this was more than 3. And then this one is square root of 8 divided by 3. I need to estimate what square root of 8 is. I need to use my table. So let's start with 2. 2 is equal to the square root of 4. 3 is equal to the square root of 9. So square root of 8 is going to be somewhere over here, but like really close to square root of 9. So we're kind of going to estimate it's about what? 3, oh no, not 3. It's smaller than 3, but very close. So 2.9 divided by 3. Again, square root of 8 is like almost at square root of 9. And square root of 9 is exactly equal to 3. So if we have a number almost at square root of 9, then it's going to be a little bit less than 3, which is 2.9 or 2 and 9 tenths. And we're going to take that and divide by 3. Normally, 3 divided by 3 would be equal to 1. Right? But this is a number smaller than 3 divided by 3. So it's going to be a number a little bit less than 1, okay? Because it's not quite at 3 yet. 3 divided by 3 would be 1, but it's less than that 3. So each person would get even less than 1. All right? So that's how we are really estimating here. Because if you notice, these two were all very close to 1. One was just a little bit over 1, and the other one was a little bit under 1. So that's really going to be the trick here when we're putting things in order. This one's going to go first, the square root of 8 over 3, because it's not quite at 1. Then it's going to be the one that's exactly at 1, square root of 4 over 2. And then it's going to be the one that's a little bit over 1, pi over 3. That should be our correct order. So square root of 8 over 3 first, got to move this over, and then basically these two got to switch places. Pi over 3 is the larger one, okay? So switch these. This goes at the end. Let me double check that it's correct. Yes. Okay, so that one's kind of tough. You're not allowed to use a calculator, so you just have to kind of keep track of, is it exactly at that number or a little bit over? If it's a little bit over and you're dividing, the answer is going to be a little bit over. If it's a little bit under and you're dividing, the answer is going to be a little bit under because you don't have enough to get to that number. Let's do one last problem. If you notice, the problems are getting more and more difficult, and none of them say that you can use a calculator. So they're really testing to see that you understand this. Without using a calculator, for this one, match each expression to the correct point. Go ahead and pause your video and see if you can try it on your own. Okay, here these are negatives. Be aware, because negative numbers do not go in normal order. Normally you go 1, 2, 3, 4, 5, 6. Here it's 9, 8, 7, 6, 5, 4. Okay, so same thing as before, I'm going to figure out what my perfect squares are. This is the negative square root of 81. This one is the negative square root of 64, negative square root of 49, negative square root of 36, negative square root of 25, and this is the negative square root of 16. Okay? So, let's see. We have s here, that's 2 times pi. We got to figure out what 2 times pi is. Remember, we can't use a calculator, so it's about 2 times 3.14. Well, normally 2 times 3 is 6, but it has a little bit more. It's 3 and some change. So we're going to say that it's about 6.3 or something, okay? And it's negative. So we're estimating because it's a little bit bigger than 3, so it's going to push that number over, okay? Let's see, negative square root of 68. It would normally be between, what? It would be between these two. It would be between negative 9 and negative 8. So that helps us out. And then the negative square root of 25 is already there. It's like right here. Okay, so that one's already matched up. Let's see, this one is the point between these two guys, that's S. Okay, so these two need to switch because, let's see, T is negative 6.3, which is right here. So these two gotta switch. Okay, and that's all you do for those problems. You use your perfect squares. Make sure that when it comes to decimal numbers that you're multiplying or dividing, that you're being as accurate as possible. No one's asking you to find the actual answer here. You just need to estimate. The whole point is to approximate, and that should help you out a little bit. Okay. So I'm going to let you go ahead and try that on your own now. Let me know if you have any questions as you work on it, and if not, I will see you in class.